Example 2 says find the sine, cosine, and tangent of the four quadrantal angles. Okay, so again, our quadrantal angles are 0, 90 degrees or pi over 2, 180 degrees or pi radians, and 270 degrees and or 3/2 pi. So what I did is just drawn out my axis here with a point at each of those angles, 1, 0, 0, 1, negative 1, 0, 0, negative 1, kind of like our unit circle. Okay, I just don't have the circle drawn here. If I wanted to find the sine, cosine, and tangent for 0, okay, using my definitions from above, we said sine is equal to y over r. Well, my y value is 0, but what is my r value? Okay, we said that r is the distance from the origin to our point. So in this case, for all of these quadrantal angles, r would just equal 1. Okay, because that's the distance from the origin to any one of those 4 points. So the sine of 0 degrees would be y over r, so 0 over 1, which is just 0. The cosine of 0 would be x over r. So x over r would give me 1 over 1, or just 1. And the tangent of theta at 0 would be y over x. So my y value is 0, my x value is 1, so that would be 0. Okay, we've looked at these just briefly on that summary sheet that I'd given you earlier, but I wanted to show you here actually again where these values come from. Okay, the next column is finding the sine, cosine, and tangent for 90 degrees or pi over 2 radians. So again, sine would be y over r, so that's going to be 1 over 1. Cosine would be x over r, so 0 over 1 is 0. And then tangent would be y over x. Okay, well, what am I going to get y over x? It's going to be 1 over 0. Okay, we can't divide by 0, so we say this is undefined. The tangent of 90 degrees is undefined, always. Okay, if I look at 180 degrees, we would be looking at the point here, negative 1, 0. So the sine would be y over r, so that's going to be 0 over 1, which is 0. The cosine would be x over r, so negative 1 over positive 1 is negative 1. And the tangent would be y over x, so 0 over negative 1 would still be 0. Okay, these values hold true as long as my angle value is 180 degrees or pi radians. Okay, if we look at 270 degrees, I'm going to use the point 0, negative 1. Again, sine would be y over r, so negative 1 over 1 would be negative 1. Your cosine would be x over r, so 0 over 1 would be 0. And your tangent would be, again, y over x, so we get negative 1 over 0, and so that is undefined. Okay, so these are our trig values for our quadrantal angles. Okay, let's flip over and look at the top of the second sheet, which talks about the signs of the trig functions. Okay, I talked about this briefly also on a previous video. It says, okay, what if our theta is not a quadrantal angle? Okay, if it's not a quadrantal angle, the sign of the trig function depends on the quadrant in which theta lies. So we say in all 4 quadrants, r is positive, however x and y can be positive or negative. In the first quadrant, x and y are both positive, and so for that reason it means that all of our trig function values will be positive. In the second quadrant, x is negative. So if x is negative, r and y are both positive. X is associated with sine, so sine and its reciprocal, cosecant, are positive, but all others are negative. Okay. Then the third quadrant, we say that our x value is negative, our y value is negative. So if x and y are both negative, then I could have a negative sine, negative cosine, but tangent would be positive. So tangent and cotangent are positive in the third quadrant. And in the fourth quadrant, positive x, negative y. So if it's a negative y, that means sine would be negative. A positive x means that cosine and secant would be positive. So also I talked about earlier what you could use to remember. All students take calculus, just to remember your quadrants there.